Hello everyone. Today we are going to continue our work with rational expressions and we're going to multiply and divide rational expressions. Spud's here to say hi again. He's a very cuddly cat if you can't tell. Alright, I am going to present the entire screen so that you guys can, and my face is getting weird on here. Oh, Bug wanted to say hi too. We'll cancel this real quick. She wanted to come say hi. That's my other cat. Say hi, Bug. Alright. We're going to present the screen now. Hopefully a cat butt won't be in my face the entire time. Share, and let's get down to business. Now, a lot of this is going to have to be done by hand. It's not really Desmos capable from what I know right now. I'll definitely look into that a little bit more for you guys. But I think you guys are more than capable of doing this. So, just like we did on Monday, the first day of this, we're going to first have to factor and then simplify. So we have x plus 1 times x minus 1. That's already factored. X minus 5 times x squared minus 1. That is not factored. That second expression is not factored. So we're going to factor it out. I'm going to rewrite the top. And it is simple to factor out because this is a difference of squares. Because both the first term and the second term are square roots. So, or have a square root, a perfect square. So it becomes, remember we do the 2, put a plus, a minus, the square root of x squared is x, the square root of 1 is 1. Now we can cancel out what's the same on the top as the bottom. So x plus 1 cancels out, x minus 5 cancels out, and since there's nothing left on the top, it's 1 over x minus 1. That is fully simplified. For the next one, we're going to have to factor, and both of them, we need to find factors of 12. So I'm going to find factors of 12 over here. I have 1, 12, 2, 6, 3, 4. For the first one, they need to subtract or be different to give you a positive 1. So we're going to need a positive 4 and a negative 3. So we have x plus 4, x minus 3. The second one, they need to add or be the same sign to give you a positive 7, which means plus 3 plus 4. So x plus 4, x plus 3. We cancel out like terms. So x plus 4 and x plus 4 are exactly the same. We can cancel them out. And we get x minus 3 over x plus 3. And that is your simplified expression. Bug, you are right in the way. And I lost a pen. Good thing I have another one. So now pause the video and you try the next two. Pause this, you try. We need to make sure we're able to do this. Hopefully you pause, going through this really quickly. Factors of 9 are 1, 9, 3, 3. They need to add, be the same sign to give me a positive 6. So we get x plus 3, x plus 3, also known as x plus 3 squared. And then that's going to be over, this is a difference of squares, so make your 2 plus minus the square root of x squared is x, the square root of 9 is 3. These cancel out, so I get x plus 3 over x minus 3. I'm going to box my answers so we have these. Okay, for the next one, for the numerator, I need to take out the GCF. And for the denominator, I'm going to have to do some factoring. So 8 goes to 1, 8, 2, 4. They need to add to give me a positive 6. So we're going to use 2, 4, both positive. In the numerator, I'm going to take out 4x because there's a 4 in both 4 and 8. And x is in both of them. Goodbye, Bug. And I would get 4x, x plus 2. And on the in the denominator, I would get x plus 2, x plus 4. And I got 4x, x plus 2 because I divided 4x squared by 4x and got x. 8x divided by 4x is 2. And then remember, we chose 2 and 4 as our factors, so 2 and 4. These are the same, so we get 4x over x plus 4. And that is our answer. So now we're going to look at multiplying rational expressions. When multiplying rational expressions, meaning you are multiplying two fractions together, you multiply straight across like we do in regular fractions. So we're going to multiply straight across the bottom and the top, and then canceling like we did above. But first, we need to factor out where possible. So I'm not even going to multiply these. I'm going to factor out and just put it all together. So I need to find factors of 8. And I have 1, 8, 2, 4. They need to subtract or be different signs to give me a positive 2. So I have x plus 4, x minus 2. And then I'm multiplying it by this on the top. I'm going to take out the GCF, and I get 3 times x plus 1. So that's going to help us see if there's anything that's like. And then on the bottom, I am going to do the same thing. I need factors of 3, which are 1 and 3. They need to add to give me 4. So I have x plus 3, x plus 1, and then I'm going to multiply it by what's in the other denominator, which is x minus 2. Now we cancel out anything that's on the bottom and the top that's the same. So I have an x minus 2 I'm canceling out, and an x plus 1 I'm canceling out. Now, as we rewrite this, we're always going to put this number in the front. So it's going to be 3 parentheses x plus 4 parentheses over parentheses x plus 3. I would probably add the parentheses in this one only because you have that 3 in the front. You might not see them in the denominator, but I would add it. Okay. We're going to do the same thing on the next one. So first we have to factor the top. This is a difference of squares. So we have a plus, a minus. It's going to be x, 3, 3. And then multiply it by what's in the numerator on the other one because we're just multiplying across the top. And then in the denominator, I need factors of 6, 1, 6, 2, and 3. And this is one where it really matters. They need to add to give me a positive 5. So they have to be the same sign. Because 6 and 1 can give me a positive 5, but they can't be the same sign. 2 and 3 would have to be what we use. Because it's a positive 2 and a positive 3. A positive 6 and a negative 1 would multiply to give me a negative 6. I don't have a negative 6 there. I have a positive 6. So it would give me x plus 2, x plus 3. And then when we take out the GCF of this one, 3, we get x minus 3. So now we're gonna cancel out anything that's alike in the top as in the bottom. So x plus 3, x minus 3, x plus 2. And so since there's nothing left in the top, it's 1, and the only thing left in the bottom is 3. Okay. Next one. I want you guys to try this before I show you how it's done. So pause the video, try it yourself. Don't wait for me to do it. You try it yourself. Okay, hopefully you pause the video. We're going to look at factoring these. And again, we're always multiplying across. So the factors of 84. 184, 242, 3, 60, 28, 4, 22, 21, 6, 6, 6, 6, 14, taking me a little bit longer, 7, 7, 12, 8, 9, 10. Nope, no more. So those are our factors. So now that I have that, I need them to add, be the same sign to give me a positive 19, which is 7 and 12. So I have t plus 7, t plus 12. And as you can see, I differentiate between my t's and my pluses by curving my t's. Hopefully that helps you. And then over here, I'm going to take out the 2 in the front because that's our GCF. And I have t minus 1. So now doing the same thing on the bottom, I'm going to take out my GCF, 4, t minus 1. And then I'm going to factor this. I need factors of 14, which are 1, 14, and 2, 7. We're going to use 2 and 7 because I need to add to give me 9. So we have t plus 2, t plus 7. Now let's cancel what's in the numerator as in the denominator. T minus 1, t plus 7. All right. And then before I write this 2/4 is going to reduce to 1/2. So in the numerator, we would have a 1. That's not important. And t plus 12 divided by 2, because it's 1/2. The 1's not necessary, so we just put the half. And t plus 2. There is no further simplifying of this. You cannot divide the 12 and the 2 and get 6. It does not work that way because they're being added in between. You cannot do that. Okay. For the next one, hopefully, again, you've already done this. I'm not going to show you how I factored. If you need me to do that, meet me on Google Meet. I'm just going to show the factors. We have x plus 3, x minus 2, and then x plus 5, x minus 5, over x minus 5, x plus 3, x plus 1. Bud, want to come say hi again? So let's cancel out the like terms. Bud, your hair is all on my stuff. The like terms are going to be x plus 3, x minus 5. And so we rewrite x minus 2 times x plus 5 in the numerator, and the denominator has just x plus 1. And that is your answer right there. And that's the basic gist of multiplying, is canceling out what's the same in the numerator as the denominator. So we're going to go on to dividing rational expressions, which is kind of going to look like multiplying. When dividing rational functions, you multiply the first fraction by the reciprocal of the second fraction, simplifying. Canceling like we did before, where you can. We call this same change flip or copy dot flip. That's what I used to call it, is copy dot flip. So if you copy dot flip, whatever is going to help you. But essentially, if I do 1/2 divided by 1/2, it's 1/2 times the reciprocal of 1/2, which is 1/2 times 2/1, which gives me 1. So just so you know, you're flipping the other. So let's try this. We have a plus 2, and then I'm going to now factor this one to get the other part of the numerator because I have to flip this. Essentially, it's a plus 2 over a plus 3 times the reciprocal of the other one. Now, I don't always write out this version. I don't need you to write out this version as long as you know you're multiplying the top by the bottom of the other. So this is a perfect difference of squares. So I would have a plus, a minus, a 3, divided by a plus 3, because that's what's here. And then we're going to factor a squared plus a minus 12 to get the other one. And factors of 12 are going to be 1, 12, 2, 6, 3, 4. I need them to be different signs and give me 1. So it's a positive 4, a negative 3. So a plus 4, a minus 3. Now we cancel out where we see like terms. So a plus 3, a minus 3, and we get a plus 2 over a plus 4. And that is your answer. Okay. For example 2. Again, it's set up like this. If you want to rewrite it, it would be b squared over 25 a squared minus b squared divided by b over 5a minus b. Now, these say state all the restrictions. We're not going to go over that quite yet. That's going to be in a later video, so don't stress about that right now. So this is the original. Now, if we flip it to multiply, it's b squared over 25a squared minus b squared times, flip this, 5a minus b over b. All right, let's see what we can do. So we're going to have to do some pulling out of GCFs. So I have b squared, which is the same as b, times 5a minus b. So we're going to put some parentheses around that. Over, I'm going to take out my GCF GCF, and I have, oh, I'm not taking out my GCF. This right here is a difference of squares. So it would be 5a, because the square root of 25 is 5. The square root of a is a, plus the square root of b squared is b. And then we do the same thing, but we're going to have a negative version. And then times b. Okay? Oh, sorry. I didn't know that. You couldn't see that. So now we cross off what's the same in the top as the bottom. And this b squared divided by b is just going to be a b in the numerator. It's going to take away this. Remember our rules with exponents is if it has like bases, different exponents, you subtract them. So it becomes b in the numerator over 5a plus b. I got that b in the numerator by doing b squared divided by b gives me b. And the denominator only has 5a plus b in it. Again, how I got this 5a plus b times 5a minus b is this right here. This 25a squared minus b squared is a difference of squares, because the square root of 25 is 5, the square root of a squared is a, and the square root of b is b, or b squared is b. All right, so now you guys are going to try. You're going to divide the following, being sure to state, don't worry about the restrictions, like I said. So just divide the following. Pause the video, you try. Pause the video, you try. Okay, hopefully you pause the video. I'm taking out a GCF of -6. So I have 2b plus, 2b minus 3 when I divide by -6. And then I am multiplying by the denominator of the other one, which means I have b minus 5, b plus 2 over, this is a difference of squares, b plus 5, b minus 5. Make sure it looks like a b and not a 6. And then 4b minus 6, I'm going to take out the 4, and I'll get b. I can't take out the 4. I'm going to take out 2. Sorry. And I'll get 2b minus 3. Now we'll take out what's in the numerator, the same as the denominator. Okay, -6 divided by 2 is a -3. And we have b plus 2 in the numerator. And the denominator is b plus 5. So again, I got -3 from doing -6 divided by 2, -3, b plus 2, b plus 5. Okay, for the next one, I'm going to take out the GCF of the numerator, and I'll get 3x plus 4. And then I'm multiplying it by the denominator of the other, which is x plus 2, over, take out GCF, and I get 2x plus 2. And then when I write this, it's a difference of squares, so x plus 4, x minus 4. Cancel out. I have 3 over 2 times x minus 4. And that is your answer. Okay, you are going to be doing this yourself on a quizzes, so I hope you have a lot of fun. You will have another Desmos activity at the end of this week, just so you guys know. But you guys are doing so well. Keep up the great work, and I hope you have a wonderful rest of your day.